last speaker, Shervin, keeps on telling me I'm gonna race through it just so people can get to the cooler at the back, etc. But just to give you a quick background, Shervin Akhavi graduated with a master's degree in civil engineering at the University of Darmstadt. His thesis was on the design of a passive row house complex, and then he came to Canada. In 2004, he joined Greensaver, and that's where we both met.
You hired me.
I'm still looking for a kickback, but so there we go. And you know, we've been close friends. We've gone winter camping every year. We last year was our first year. Haven't gone. What was it, like 10 years in a row?
Yes.
But building Quincy's. So yeah, we are. You know, we're good friends as well. So that goes beyond. I didn't even write that down. Why am I telling you this? So he's done commercial energy audits for commercial and large ecclesiastical buildings at Greensaver, and then there's the work that we've done here at Blue Green Group. It's, you know, quite a bit of stuff. He's currently a founding member of Passive Buildings Canada. He sits on the board of directors, and as I said, he's my business partner, etc. Without further ado, Shervin, here's the baton. Utilize it.
Thank you, everyone. I'm really grateful to have you all of you here. And again, I'm just going to be very quick because, as Greg said, the beer and the wine is waiting for us. So this is just a quick brief report from our visit to the Passive House conference. And I really recommend anyone who's interested in building science to at least once go to this conference, because it's really, when it comes to building science, is the best in North America that you can find. I've been to many conferences, and this is, to me, the best. And I call it also my annual motivational session. So I need it to keep me going. So it's a mid-size conference, I would say, and it's really interesting to watch, you know, how it's been evolving in terms of size and also issues that we're talking about, or problems and solutions and equipment that, you know, every year when you go there, you can see. This is our little Canadian group. I realize it's not really that visible, but I'm afraid. Oh. So, and also Chris and Stephen didn't make it to the group photo, so I had to take a photo of them extra. Yeah, it would take some time. You know, I'm a perfectionist. So, there were a number of presentations from Canadians. Mike Anderson from Passive House E-Design from Nova Scotia. He's working with Natalie Leonard, and he had a case study. And I have to say, Nova Scotia is the hotspot for certified passive houses. And the question is why? Well, they don't have natural gas. And they have some incentives to cover for you know, energy modeling and testing, and that's where you get projects in ground if the economic environment is encouraging efficient design. Terrell and Sylvia gave a joint presentation on round there, we just heard it. Stefan and Ross. Stefan is actually here as well. They had two presentations. One was a case study, a new passive house going up in Ottawa. And the other one, which was really interesting to me, was an update on Net Zero R2000 and the new energy rating system. Matt of Second Lot, he's also a former student of Russell. He presented his thesis, which was really interesting because of the methodology. He basically optimized performance and cost, and his methodology was really interesting. I'm not claiming that I understood everything, but I hope that he would be here tonight. But that's really a good, an interesting presentation as well. Stephen Gray of Greening Homes did another presentation on the Andrew and Maria's house that we just talked about. And last but not least, Hayes, who is now with Rocky Mountain Institute, but he's a former student of Russell as well. So he did a presentation about Rocky Mountain's Institute's new center. It's a new building that's been built to the Passive House standard. Now, I want to talk about one presentation and share it with you. And this is not my presentation. I'm just referencing his presentation, Colin Chang from RDH. He's a Canadian as well. And it's about cladding attachment to exterior insulation using long screws. And why long screws? Because that's the way how we can reduce all these thermal bridges that tremendously degrade the insulation value. As you guys know, there are many ways of attaching exterior insulation, like these Z-girts, vertical, horizontal, clips, galvanized stainless steel clips, clips with a little plastic behind it to reduce that thermal bridging, Cascadia clips, fiberglass, and plain and simple, screws with strapping. And this presentation was about the strapping, using the screws. They did a 3D thermal finite element analysis using E3, which is a German software, so it's accurate. The boundary conditions that they used was minus, if I'm not wrong, minus 18 is 0F, and 70 is plus 21. So, and that's the result. Just to explain what we're looking at here. So these are the various methods of attaching the exterior insulation, with the brown one here, starting with continuous vertical Z-girth at 16 inches, and then the second one is at 24 inches, and so on. And the last one, the last two are the screws. So they have done an analysis for 16.8 on the exterior, or 33.6 on the exterior, and 50 on the exterior. And here we can see the effective R value. Of course, the Z-girts reduce the effective R value tremendously. If you look at here, this is, I think 60% less. And the more insulation you put, the bigger the degradation of that effective R value is. Or, putting it a different way, this is the percentage thermal degradation. So, as we expected, the continuous vertical Z-girts, which are tremendous thermal bridges, with our 16.8 on the exterior, that insulation has been degraded by something around 65%. If you have 33 R33 on the exterior, the degradation is close to 75. And the more insulation you have, the larger the degradation is, close to 80%. And again, on this side, you can see the screws. Sorry. And, just keep in mind, the insulation, the nominal insulation is the same in these walls. It's just that those thermal bridges degrade that thermal insulation by far. And as you can see, there's a tremendous amount of difference there. Now, one of the questions was that, okay, so how, like, structural, how, can it hold it up? And just to give a perspective about, how heavy various types of claddings are, you can see here, like brick is 40, vinyl or fiber cement boards, 2 to 5. For example, if you have a 16-inch screw at 16 inches screw spacing, the fiber cement board applies a force of about 9 pounds per screw. And I will get to a little bit to the structural part. The point is that the screws apply a force to the strapping and the insulation, which creates friction. And that friction does a lot. And basically, over 20 pounds of vertical resistance per fastener has been reported. We're talking about 9. So there is no problem, according to them, of attaching any kind of cladding using screws. Now, if people are kind of concerned about the weight, then, this insulation, they can use shear blocks so that the strapping is hung on these blocks, and it gives more structural strength. However, this can be also intermitted to reduce thermal bridging, so we don't need this shear block between the straps. So, it can be done that way as well. So again, they're emphasizing that this is not necessary for lightweight cladding. And I think I would listen to them. Now, the next item I want to talk about is a new ventilation system. It's a heat recovery ventilation, but not in the classical sense. It's called the SERV, Conditioning Energy Recovery Ventilator. It doesn't have a heat exchanger core like any HRV, where the outgoing stale air, warm air, heats the incoming fresh air. The heat exchange happens via heat pumps. And as you guys know, heat pumps don't generate any heat. They just move heat from one side to the other side, just like your fridge. The fridge is a heat pump, removing heat from the inside of the fridge and putting it on the back side. That's what this system does as well. And the neat part is that it does partial heating and cooling as well, which is distributed. So it's suitable for our climate using a mini split, which does partially the heating and cooling in the shoulder season, the heating and cooling in summer. But then, that might not be enough for certain areas in a house, so that this system can help distribute some of the cooling and heating as well. So it really, they were saying it was I'm going to show you some photos of some projects. And for our climate, with really cold winters and hot and humid summers, this is apparently a good system. So none of these systems have been installed in Canada. The first one is going to be installed in the fall in Montreal. And check it out. Now, want to also talk about what Sam Rashkin, he's the chief architect at the Department of Energy in the U.S. He gave the closing plenary keynote on words. That's interesting. Everyone scratched his head and said, words? Yes. I think each of us has been in that position talking to a client and trying to explain complicated technical things and just overwhelmed the client, lost the client. I think each of us had that experience. I had it, I've done it, I've been there. So and that's about that, how to use words to convey a message, but also help you to convey that message and not defeat you. For example, and this is Sam Rashkin, this is an excerpt of Sam Rashkin's presentation. He says it's really difficult to say Patagonian toothfish, but it's much easier to sell Chilean sea bass. Or energy audit. Energy audit. Yeah, nobody likes an audit. It has a negative connotation. Everybody is afraid of an audit. And we're trying to sell energy audits. According to him, it's much easier to talk about an energy checkup, like a health checkup. That has a positive connotation. And, he goes on and on. He talks about fossil fuel being a substance and our addiction to it, abusing that substance. And the presentation is on FIAS's website, and you can check it out. It's really refreshing. Also, he pointed to a document done by the Department of Energy. I have a copy here, printed out if you want to have a look at it. It's a building science translator. And there are some terms that is really interesting if you look at it and try to put yourself in the shoes of a client. And we're talking about complicated stuff. I don't want to now go through some of the terms, but for example, exterior insulation. Why don't we call it continuous exterior thermal blanket? Blanket is pretty clear to client. Everybody uses a blanket at night, and it's continuous. So the whole thing with the thermal bridging of the studs, that's not a blanket. It's intermittent by the studs. So that's the idea. So also part of the conference is on the last day, you can sign up for a tour of the projects. And because Chicago has a similar climate to our climate, it's interesting to see how they do things there. And, basically can apply that here as well. So this is a certified passive house. Just to tell you, there was some comfort issues in this house because there were some shading devices planned, but the client didn't install them. So basically, they had some overheating issues. As you can see, they installed a film on the east and the west side. You can see this here to mitigate that problem. But it was still a problem, and it really doesn't look good, looking out of the window to a film like that. The heating system is a mini split, and that's basically it. A mini split. This is the water heater, and they have also a thermal solar panel, and that's the tank for it. Now, what helped them resolve the problem was to install the serve, because the house was experiencing some overheating in certain areas. The mini split was doing its job, but that cooling was not distributed. However, the serve helped them to distribute some of the cooling that the serve does as well. and that basically resolved their problem. This is another house. I like it. It's really a small house. It's a slab on grade, and as you can see, it's been, basically open to the south to make use of the solar energy there. And again, it's, an urban setting. So in order to maximize that solar gain, they opened it up to the south so that, the house on this side is not really affecting it. If you look at the thermal, if you look at the shading, and this is, September 11th. That's the overhang. So, and they have a fireplace, but the fireplace is not in the thermal envelope. It's a big no-no for a passive house. But you can still have it. We're humans. We're geared towards, fire. We like radiation. And that's how you do it. You put it outside in a 3-season room. This is the mechanical system, the Xander heat pump water heater, and the mini split. Plain and simple. The idea of passive house is to reduce mechanical systems, the complication of it. Now this one is interesting because this house doesn't, the goal was to achieve the living building challenge. So that was the goal, and they did certain things differently. As you can see, they have a weather barrier here, but that's not really needed. This is an extra thing they put on. This is a blue skin. But basically, they have 6 inches of Roxol, semi-rigid Roxol on the exterior, 2x8s, and insulation between the studs. Now, here you can see the 2 layers of Roxol, and the air barrier is on the sheeting, is a liquid applied air barrier. Here on the back side, you can see it as well. So the weather barrier, the insulation, the air barrier, and then in between the 2x8 studs inside as well. And that insulation goes all the way down, covers the basement as well, like a blanket. And the basement is not concrete, it's Durasol with Roxol insert in it as well. Some air sealing on the windows here. You can see again the liquid applied air barrier. On the top floor, the air barrier is also, that liquid applied is applied to the ceiling as well. And again, the Xander was the heat recovery ventilator, and that was it. And the heating system was a mini split as well. This is another project we went, and it's not a fort. Nobody is going to shoot at you from the top. Those are in place for the roof trusses. It's a raised heel roof truss to enable enough insulation around the perimeter of the attic. So, and they use the zip panel, zip sheeting, and again, that's an air barrier as well. Now, zip is from south of the border. We have something similar here in Canada as well. It's the XL sheeting. It's a structural sheeting, so it substitutes the regular sheeting as well. And here, I was hoping Stephen was going to be here because I don't remember why they applied the tape and then they experimented with the fluid as well. But there was something going on there. But as you can see, this is on the inside, that fluid, the liquid applied air barrier is oozing in. It's really sealing that joint of the sheeting. Here we can see the seal gaskets sealing this is the zip panel, the concrete. Seal gasket here and there to make that perimeter airtight as well. And that's it. Thank you, and